Bismillahirrahmanirrahim. So today we will discuss about the steady state analysis in RLC network. Okay, that means the sinusoidal. Okay, sinusoidal. Sinusoidal steady state analysis. Okay, steady state analysis. So it's very easy to analyze the circuit by using the phasor representation. You are actually already familiar with the KVL, KCL, all the circuit laws, everything. So you can use those concepts here also. So I will just do one example. That is enough, I think. And other things you can refer, inshallah. So it's because of our time limitation, one of the main, that is the main constraint. And I will do one example. That is enough. If you are very well experienced in solving the DC circuit, then you can apply the same principle. But only thing is here we will have complex numbers. That's it. So you should know how to deal with the complex numbers. So first of all, I will tell you first. I will give you an example. There is a resistance, a capacitance. We are talking about the steady, not transients. There is an R2. There is an inductor which is L2. Okay, there is another inductor here which is L1. Okay, now you have a source V of t, and your V of t is nothing but Vm. Okay, I will write it other side. Okay, you have a source of t, and this is the circuit, and V of t is given Vm cosine of omega t plus phi. Phi is the phase of the cosine signal. Okay, so we will solve this kind of problems by using phasor. Okay, by using phasors or by using phasor representation, we will say. So we will convert everything into domain. So convert, the first step, convert to phasor domain. Okay, phasor domain. So we will use the phasor representation. So what will be the voltage phasor? First of all, we will tell you. I will tell you what will be the phasor representation now. It's very easy. I will draw the circuit. This is R1. Okay, and you know there is L1, and there is a capacitor which is, and this R2, and this is L2. So it is a RLC circuit actually, and which is connected in a different way. And you know this is the circuit. Am I correct? This is the circuit. Now, can you tell me what will be the phasor representation for the voltage? Voltage, how we will represent in phasor?
Just Vm and theta, phi.
It will be the
Yes,
voltage and
yes,
rectangle.
Vm and phi. Okay, this is our representation. It's very easy. After that, in phasor domain, we will mark all the current. You know how to write the mesh equation. It's very easy. Same procedure like in DC. Okay, nothing different. But you are solving by using phasor. Okay, there is no other difference. So can you tell me by using, this is loop 1 and this is loop 2. Okay, not L1, L2. I will write loop 1 and loop 2. Otherwise, it will be confusing. Loop 1 and 2. So for loop 1, what will be the equation? Just assume that
Minus
your
Vm.
phasor now it is like this. This is plus minus. Just assume like this. So the current will be moving like this, plus minus. This is plus minus. Okay. So minus Vm
Minus
angle
Vm
phi.
theta.
Okay.
Plus
Yes, angle phi. Okay, it is not theta. Okay, theta will be represented like this. This is theta and this is phi.
Phi, sir.
This is phi. Okay, this is theta.
Sorry, yes.
Okay, don't be confused.
yes.
Okay, so then plus 2 I1, then plus what will be next?
C dV by
I1 is going down, I2 is going up. No dV by dt, nothing.
I1
We will
minus
use the phasor representation for L1. What is the phasor representation for L1? It's J omega L1. Am I correct?
Yes.
yes, sir.
Yes. So we will use that. And so what will be? It will be, what will be the
I1
current?
Omega L
It's
angle,
J omega will be the J omega L1.
angle 90.
Don't we will convert later. That's another thing. I will write it in this form. First, J omega L1 is the reactance, not reactance, we will say impedance of L1, right? J omega L1
Yes.
is the impedance of L1. You know, L1 will be J omega L1. What will be X L1? X L1 is omega L1. This is the difference. X means there won't be J. Z
Doctor.
means there will be J. That is the, yes.
What do you want to find in this circuit?
Yes, I am going to solve this circuit for finding the currents, I1, voltage, everything. Okay, complete solution for the circuit.
Yes, sir.
I will not discuss, I will not completely solve the circuit, but I will just give you the idea. And this idea is applicable for any circuit. Okay, you can solve any circuit. If you know
Yes, sir.
the DC response analysis, if you know how to solve the DC circuit and how to write the KVL, KCL, if you know that idea, you just need to transform the circuit into phasor and use the same idea. Difference.
Yes, sir.
And you should know how to work with the complex numbers. You should know how to work with the complex number. That is the main issue. So
Yes,
what
yes,
will
we
be
know, sir.
the voltage across? Yes, what will be the voltage across L1? Please tell me. J omega L1 is the impedance multiplied with
I1 minus I2.
I1. Yes,
Minus I2.
I1 minus I2. Don't miss this. Yes, this is to 0. That's it. Loop 1. Got it?
Yes,
So
sir.
we use
Yes.
here mesh analysis,
Yeah.
Now,
right?
just a mesh analysis. Very simple. That's what I'm saying.
Yes.
It's very simple. If you are very thorough in DC analysis, if you are very thorough in DC volt handling with KCL, KVL, you just need to, you can write the equation like in the same way, but everything is in complex number or phasors.
Yes.
You understood? That's it. Now we will say loop 2. In loop 2, I will start with the capacitor. I will start with the capacitor. I will start from here. So capacitor, what is the reactance of the capacitor? 1 by J
1 by J
omega
omega
C.
C.
1 by J
Right?
omega L. J omega.
And what about this guy? What about the L2? J omega L2. Am I correct?
L2. Yes.
Yes, sir. Yes.
Yes. Now I am going to write the equation. I am starting from the capacitor. So you can see I am going to mark like this: plus minus plus minus plus minus. Because why I am considering like this? Because I have considered my I2 in the clockwise direction. That's why. Okay, that's why.
Yes.
Yes, sir. Yes.
So when I am moving, so when I am talking about I2, I will assign for L like this,
Plus minus.
because
From,
I'm
down.
yes, because I am talking, I am in loop 2, then I am assuming that my I2 is greater than all other current. You understood? I have told this idea before.
Yes, sir.
So I am going to write the equation. So 1 by J omega C into I2, right? Plus R2 into I2, then plus J omega L2 into I2, then plus J omega L1 into I2 is now bigger, I2 minus I1. I will write it in the next line. There is no space here. So plus J omega L into I2 minus I1 equal to 0. So you have now two equations. Now there are equations 1 and 2. You know what is the voltage, what is the angle, you know what is R, you know what is J omega L1, and here also you know what is J omega C, you know what is R2, you know what is J omega L2, everything you know. But so you can solve I2 and I1. Am I correct?
Yes.
Yes, sir. Yes.
You have
Yes.
two equations, two unknown. So you can use any method. You might be knowing the determinant method. Determinant method, you know. I1 is equal to delta 1 by delta. I think you are very familiar with that method. I am not going to
Yes,
solve
yes,
this.
yes.
Okay.
I have heard it
Yeah.
about it.
But
Yes.
the only thing you should be very careful. Only thing you should be very careful is that you are working with the complex number. That's it. Nothing else. If you know how to work with the complex number, everything is same. So you know you can find now I1 and I2 as delta 1. This is delta 2 by delta. Okay. After that, you will be getting I1 as some value with angle, right? Some magnitude and angle. Am I correct?
You're right, sir.
Yes.
Yes.
Yes. So both I1 and I2 you will get like this. And so if you know that, okay, you can take this I1 will be having magnitude and angle. Okay, angle, some angle, not 5, maybe some other number, angle. Then you can find the actual current. How actual current will be in time domain? How you can find the actual value in time domain if you know this thing?
What do you
It
mean,
will
sir?
be positive.
If you know the
value.
phasor, if you know the phasor, you can write I1 of, am I correct?
Yes, sir. Yes. Of course.
How you can write I1 of t?
By knowing omega multiplied by E of
Yes,
J
you can
omega
just write like
T.
this. You can write it as, you can write I1 of t like this. Sorry, you can write I1 of t. It has a real part of I1 and e power j omega t, right? This contains magnitude
Yes.
and angle, right? This
Yes,
is
sir.
representation, basic representation. Yes. Similarly, we can find of t as real part of I2 phasor I2 and j omega t. So this will be the solution. So this is the method. I'm just giving only the method because of the time constraint. So this is the method for solving any problem. You understood? The
Yes,
only
sir.
thing you are working with the phasor. So if you know the phasor representation, first convert the AC circuit into phasor representation, write KVL, KCL, whatever required for the circuit, and try to find the values like I1, I2. Then you can find, if you know I1, I2, you can find voltage, right? Across
Yes.
each element.
Yes.
Yes.
So that's it. So it's very easy. So it's not so difficult.
That's
So the
only.
only thing you should know. So, sorry.
That's only in steady state. It's valid only in steady state.
Yes, steady state. But the transients means you have to solve the differential equation and you should get the solution. Then you know how the transient will give you the solution. Then there will be two constant in a second order system. Then by using the initial conditions, you have to solve for two constants and get it. You understood?
Yes, 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 sir.
So that is a little bit difficult. And we have a lot of software tools for all those things. We don't need to worry about this thing, but we should know the concept, how it is solving, how it is working. You
Yes.
understood? So blindly don't use any software tool without knowing what is inside, how it is functioning. Without knowing its function, don't use blindly any software tool. I know many people, many people I know, they are using the software tool and they don't know what is inside and how it is working. So whenever they get a real problem, they could not analyze anything. They will just see the output and they will not realize what is happening here. You
You're
understand?
right, sir.
So whenever you are using a software tool, definitely before that you should know what is the theory behind it, what is the working principle. Then you can get the idea. This manual calculation of these mathematical steps and all, it will take a lot of time. So the software tools will make our life very easier. But if you blindly follow the software tool without knowing the theory behind it, that is utter nonsense. You understood?
You're right.
That is
sir.
the
Right.
yes. That's the main thing. So now we will talk about another thing which is known as the phasor diagram. So just now I have explained how to solve any circuit by using phasor. You can use the analysis exactly whatever you have studied in DC, but everything is in phasor domain now. That's it. After getting the answer in phasor, you convert back into time domain equation. You understood? That
Yes,
is the main
sir.
idea. Yes. So the steps in are steps. I will just conclude here. Steps. Sorry. The steps are: first step, convert the circuit into phasor domain. Phasor domain. Okay. Then write KCL or KVL, whatever required, and solve and get answers. You will get the in phasor domain. Then convert the answers in phasor domain to your actual time domain equation. You understand? These are all the steps. That's it. The remaining things are as we have discussed in DC analysis. You understood? That's it. This is the step.
Yes, sir.
So you can use these steps for solving any circuit. Now we will see another thing, the phasor diagram. That is very, very important thing. Phasor diagram is one of the very important thing that may be very much useful in understanding the machines. Okay, AC machines and is not AC machines. Okay, so phasor diagram. Do you know this phasor diagram?
A little bit.
I
Yes, sir.
heard about
Anybody?
it. I heard about it, but
Sorry,
I heard about it.
not clear. Okay, so
Yeah.
okay, the phasor diagram, actually the phasor diagram, it is nothing but the pictorial. It is a picture. Okay, pictorial. It's a pictorial representation. Okay, pictorial representation. Okay, of all phase voltages, and their respective currents in network. Okay, so phasor diagram, it will contains the representation. It is a picture which is used to represent currents in the network. Okay, so not diagram, actually it is in the diagram. So in the network, so it is a diagram which contains all the phase voltages and their respective current. That means it contains the current and voltages, and we are representing it by using some lines. Okay, and with that it is very easy to obtain. If we are representing something in a picture, in a form of a picture, then physical interpretation become very easier. Our life become very easier. Okay, that's why we are using
Yes.
these kind of diagrams. Okay, so first of all, we will see the series circuit, series RL circuit. Okay, series RL circuit. You know the series RL circuit will be applied with a voltage. Let's say V is the voltage. Okay, V is the voltage, which is a phasor. I am saying it's a phasor. You know what is phasor representation? V is a phasor. It will be having a magnitude, angle. That's it. Okay, and you know this is R, and there will be an inductor. This is okay. In RL circuit, you will be having a current which is a phasor I, right?
Yes, sir.
Yes.
the current through the resistance and current through the inductor, both will be same or not? Both will be in the same phase, right? Because current is series, are series.
Sure, sir.
That's why. So current will never make any difference. You understood? Current will be same for both R and L. Right? Current
Yes, sir.
Yes.
will be same for both. In both means same means what? Same in magnitude and also in phase. Right?
Yes, sir.
Yes. Yes.
Yes. So current will be same anyway for both. We can have, so if current is same, I will take my reference as current. So I will represent my current like a straight line like this. And this is my reference because current is same. You understood? That's why I am using. If voltage is same, then I will use my voltage as the reference. When it will be voltage will be same. Voltage will be same if R and L
If it's
are parallel. Am I correct?
It's
If
parallel,
nothing
yes.
Yes.
same,
But here it is
what we
series.
do?
Sorry?
If there is nothing same, what will we do, sir?
It will be something will be same. You know, in a parallel circuit, voltage will be same. In a series circuit, the current will be same.
But
That
in
is the
some
idea.
complex
You understood? In complex circuit also, you can decompose like that. In machines, you will learn about it, inshallah.
Yes, sir.
So this is I. So you know that what will be the voltage across the resistor? Voltage across the resistor now. Voltage is equal to I into R, right?
Yes. Yes.
Yes, sir.
Across the resistor. So resistor voltage, you can see it does not contain any complex number. So it is everything is real and it is not changing any direction since there is no complex
Same
number.
line.
It is just a magnitude, right? There is no other phase for it. Am I
Yes,
correct?
sir. Yes.
Just only magnitude.
Yes,
An
sir.
angle is zero actually, no angle. So it doesn't make any change to the direction. So the voltage across the resistor will be in the same direction as that. Am I correct? Like this I can show.
Sir, yes.
Yes. Now I am talking about the inductor. Inductor voltage will be I into j omega L. You can see there is a magnitude part and there is an angle
90,
part. You know what is J? What is the angle for J?
90, sir.
Yes. So I will draw from here because it doesn't make any difference to draw from this point or this point because you know if I shift, I can shift the vectors. You know this idea. I can shift the vectors. I can shift like this. There is no problem. You might have studied in high school. I don't know whether you have studied in high school. We can shift the vectors.
Yes, yes, right, doctor.
So I will represent like this because this is 90 degree. 90 degree with respect to our VR. VR is 0 degrees now because it is in same direction of the current. So this guy will be 90 degrees and this will be the voltage VL. So it is 90 degree, you can say it's 90 degrees because of the J. Now you know how to find resultant. How to find the resultant vector.
It is
If
that
one vector
between
is active, yes, it is one vector is active like this. If two vectors are like this, the result will be like this. The third part, it is known as the triangular law of vectors.
You're
Triangular
right.
law of vectors. So I am not explaining this thing. So you can refer any
Total
mathematics
voltage
books.
of the
You
circuit.
can. Sorry.
This vector is the total voltage of the circuit.
Yes, yes, yes. It is the total voltage of the circuit. Sorry, I am. So you can see this is the total voltage of the circuit. My V, you can see this, and this way both will be same. And how to obtain the magnitude of V now? what will be the magnitude of V? You know, by triangle, it is a right angle triangle. So the magnitude of V will be square root
The
of
square root
VR square plus
VL
this is
square.
VL plus VL square. And this is the angle phi. I can say it is phi. How to find the cosine of phi? What is cosine of
Tan
phi?
inverse VL by VR.
Not tan. No. I am talking about the cosine of phi. Cosine of phi.
It is
What will be the cosine of
VL
phi?
by
VR
VR.
by V. VR over V.
VR by V, sir.
VR over V. VR by V. Right. This is the cosine of phi, and we will call this as the power factor. I think you might be heard about this power factor.
Yes, yes.
Yes, we heard about
That
it.
is the power factor. Now I will just next page for the representation. You can see this is the direction of the current. This is the VR, and this is, and I have the resultant vector like this. Okay, this is V. So magnitude of V is equal to square root of VR square plus VL square, and my cosine of phi is equal to, if I know VR, then just it's VR by V. It is nothing but the, what will be the value, what will be if VR equal to V, then what will be cosine of phi?
It will be 1, sir.
Well,
It will be 1. Then what will be phi? If cosine of phi equal to
Will
1,
be
phi
0,
equal
sir.
to,
0.
it will be 0. Then what will be the nature of the network? The nature of the network will be
Resistive.
whether it will be resistive or inductive. Sorry?
Resistive, doctor.
Yes, because how you are getting VR equal to V? VR become V only if situation. You have VL here, this is VR here, and your V is here. Now your V should move down, and you will get VR same direction. Am I correct?
Yes.
Yes.
This is possible only if VL should be equal to 0, right?
Yes, sir. Yes.
If VL is 0, J omega L should be equal to 0. Omega is not 0, so L should be equal to 0. Am I correct? VL 0 means what? What is VL? VL is I
It
into
is
J omega
radial.
L. That means this is 0 means L should be equal to 0. That means the network should be resistive. The network should be completely resistive. That means the network will be like this. Yes, you have a voltage like this, like this. This is nothing but a resistive network. So if cosine phi equal to 1 means pure resistive. Pure resistive. Okay. If cosine phi reduces, what will happen? Let's say if cosine phi is equal to 0.9, it is having resistive and inductive, right? But which is more?
Right.
Which is more?
Yes.
But which is more? Which is more here? Which is more here? R or
Conductor.
L?
Resistive, I think.
L. R.
Yes,
L.
it's more. The R is more here. This guy is more here because the reactance for L is J omega L, and this you see 1 means pure resistance. That means only R. L equal to 0. If
Yes. Yes.
0.9 means it contains both R and L, and R is, now what will be the situation? Cos phi equal to 0.5. That means it's both are
50-50.
Balance.
yeah, both
50-50.
impedances are same, both 50-50 like this. Now if cosine phi is 0.1, that means the R and L will be there,
Conductor.
but L is more. right?
L more.
Yes. Yes.
L more means what? I am saying ZL is more, right? That is the meaning. ZL is more. L more means what? ZL is more. ZL means what? ZL means J omega L. Okay, that's it. So that is the idea. So this, can you tell me, my reference is here. This you can see there is an angle. I will say one more thing. My current, this is very, very important point. My current is lagging the voltage. Am I correct? Am I correct? My current is lagging the voltage.
Yes, you are correct, sir.
Yes. Why?
Why, doctor?
This is I.
Because the L.
This is, you see here. This, see here. This is VL, and here this is my V. Okay. Now this is my applied voltage actually. This is my applied voltage. And you can see this is the angle phi. We usually consider the angle phi like this. This is positive, and if something is moving down, if something is like this phi, this first one is positive phi, and this is negative phi. Lagging means it is behind. Leading means it has overtaken. You understood? Do you know what is the meaning of lagging and lead? Yes. Yes. So here you see who is above I. Who is above I?
V.
I is the reference. Yes. So I can say it in two ways. I can say in two ways. One way, my V is
The voltage
leading
the current, right?
I. Or I can say in another way, my I is lagging the voltage. You understood? I is before the voltage, because if you see from here, your voltage is more. Voltage is having more angle. You understood?
Yes, yes, sir.
Because, yes. So voltage is leading the I, or we will say I is lagging the voltage. But we will not use this convention. This is also correct. The second one is also correct, but we will use always this one. We will not use this, not use always, but you should understand this is so true. This is also true. Okay, this is also true, but we will not always use. Why we are not always using? Because I have my reference as I. You understood? My reference is I, and this is my applied voltage. Always calculate in terms of applied voltage. You understood? Your V is the input and I is the output. Am I correct?
Yes, sir.
Yes.
So you will always say like this: my output is lagging the input. Do you get the point what I'm saying? Output is lagging the input. That means your
In this case,
I
or L will.
is lagging. Always you should know what is the output and what is the input, because you are giving the input, right? You are the person who is going to give the input. Then you are observing your output. Then you should say what has happened to the output. You understood?
Yes, sir. Yes.
Your output is lagging. Why it is lagging? You know that inductor is having a property that it will not allow the change in the current instantaneously. So current cannot go fast. Go fast means it will be always before the voltage. You understood?
Yes,
If the
sir.
voltage is in 90 degree,
Yes,
if the
yes.
voltage is having 90 degree, if the voltage is having 90 degree, the current will be sometimes having 60 degree. That's it. I will tell you, it will be like this. suppose this is your voltage. This is your voltage, cosine wave, exactly. But your current will be after delay. Your current will start after the delay, like this. You understood?
Yes,
It will be
yes.
having a delay. Yes. And you can fill this thing also. Okay, you can fill this thing. So it will be like this. This is your I. So it is always lagging. This is nothing but the lagging. Okay, you see this point first and this point first, and between these 2 points you can see some angle, and this angle is phi, and the cosine of this phi will give you the power factor. How much? The amount. Cosine, if we are talking about phi, means it's a big number. Am I correct? Phi may be angle 90 degree like this, 180 degree. It is a big
Doctor,
number, not 180 degree, 90 degree like this. Yes.
the power factor, it's only on the power, or just always we can apply on current or voltage or whatever be? Because I study power factor only for power. If you have real
No,
power,
no, no, no. This is the volt.
you have
Power factor is actually coming from this relation. Power factor is coming from this relation. Because why it is coming from this relation? You know, the power of the circuit is nothing but the voltage into current, right?
yes,
Voltage
sir.
into current. But both are not in the same angle. One is this angle, this is the voltage, and this is the current, right?
Yes, sir.
So you have to project this guy this direction. How much will be there? This is phi. Then how much will be there in the direction of current? In the direction of the current, how much will be the component?
Yes, sir.
It is nothing but V into cosine phi. Am I correct?
Yes, sir.
By triangular law, you know there are two components. You can V cosine phi. This angle is phi, and this component will be V of sine phi. But we want in this direction as the direction of the current, so you can see it's V into cosine phi. Now you know the current and voltage, now you got in the same direction. Now get the power is equal to V cosine phi into I. V means voltage, okay, not phasor. I am saying it's a voltage V of t and I of t, and a cosine phi is there. So you can see the power in the circuit is depending upon the phi. Am I correct?
Yes,
The
sir.
power is a function of phi. What will happen if phi equal to 90 degrees? The power of the
This
circuit,
mean no real power.
no real power will be there actually. Okay, so this
You're
kind
right.
of situation will arise. You can study this in power systems. Inshallah, you will study it in more detail. I don't know. Dr. Abdulaziz Saidi may be teaching you. I think so. Have you studied power system before?
No, I have not, sir.
Inshallah, maybe you will be studying this thing. Okay, so at that time you can relate. If you have
Inshallah,
any
sir.
doubt, you can inshallah. So this is the idea. So you can see now lagging leading concept. So we have seen now this concept, lagging. Current is lagging the voltage. That means the current is not that much fast with the voltage. That means you can see, imagine like this. You and your friend is walking. You are walking here, and your friend is walking behind. You understood?
Yes, yes, sir.
Both are having same frequency. Both are having same frequency. That means same speed. Same speed. You can say this
But
speed
in
and this
different
speed is
position.
same. But you are in the front position. Friend, you means actually I am talking about the voltage U, and your friend is the current. Always the current will be following the voltage. Okay, both will come together, and the delay between these two guys, it's the angle, that's phi. You understood?
Yes,
That's
sir.
it.
Yes.
That's the idea. So why you are delaying? It is because inductor will always try to oppose the current. You understood? You know what is the behavior of the inductor? Inductor will always try to oppose the current. It doesn't like the change in the
depend on
current.
the current.
Yes, it is always try to oppose. Okay, it doesn't like the change in the current.
Yes,
If the current is a steady
because of
value,
lens
it
current.
has no problem. But here the current is a sinusoidal wave. It is always changing. So this guy doesn't like it. Inductor doesn't like it. So he will not allow the current to overtake the voltage, or it will not allow the current to come along with the voltage. You understood? That is the problem.
Yes, sir.
So yes, I hope it is clear, Abdulaziz.
Yes, it's okay.
Okay. Now we will see another problem, not another kind of circuit, which is series RC circuit. It's the series RC circuit. What will happen? And here we have a voltage phasor we are giving, and this is the current. So this is R, this is C. Here also you can see that the current is same throughout the circuit. So what will be the reference for phasor diagram?
The current
The
is the
reference will
reference.
be, yes, because current is same. That's why we are taking current as the reference. So don't confuse like this. You should not have any confusion, because whatever it is same, that will be the reference point. So this is the reference vector. Now you know that the voltage across the resistance will be I into R. You can see there is no complex number here. It's everything is real. So it will be in the same direction as VR. So it will be in the same direction. Okay, VR. Now what about the voltage across the voltage phasor across the capacitor? Voltage phasor across the capacitor. It is having a reactance 1 by j omega c. So it will be I into 1 by j omega c. But you know that 1 over j, what is 1 over j? 1 over j equal to minus
J. Minus.
That means this is, yes. So what is minus j? You know that plus j is 90 degree. So minus j is the mirror image of it. So it will be minus 90. Am I correct? This is j and this is
Yes,
minus
sir,
j.
yes.
So it will be going down like this. So this will be your VC, and VC you can get it by this formula. Now what will be the resultant? The resultant will be exactly like this. This will be my result, and this will be my voltage. You understood? So the angle will be
Yes, sir.
some phi. So now I can easily add the equation. What will be V? My V will be square root of VR square plus VC square. What is my VC? My VC will be I by omega C. Am I correct?
J
You
omega
can take
C,
the
sir.
magnitude. J omega
Yes,
C
the
is
magnitude,
there,
yes,
but
right.
we are, because we have already shown 90 degree down.
Yes,
So
yes,
we
sir,
just
yes.
need only the magnitude.
Agree
Okay,
with you.
we just need only the magnitude. So you can see here this angle is minus 90 degrees. Now you can see this is my voltage. Now what will be my cosine phi? Cosine phi will be VR by V again. But is it leading or lagging? I will talk about my current. Input is
The current is
the
leading, sir.
voltage. Yes, output is the current. My output dash input, that will I be writing. That means output is the current. My current is above the voltage, right?
Yes.
Yes,
Current
sir.
is leading the voltage. You understood? Or I can say,
Opposite the previous case.
voltage is lagging the current. Am I correct? Is it both are true?
Yes, sir.
Anyway,
Yes.
but this is more preferable. This is more preferable. Okay, this is also true. The second one is also true. Voltage is lagging the current means what? The
Because
voltage is
we have the
before.
current.
Yes, the voltage, this current is walking like this, voltage is walking before it. Why the voltage cannot change immediately? It cannot go
Because of
fast
the
as,
Because of the
it,
capacitor.
yes, capacitor will not allow the change in the voltage immediately. That's why the capacitor will always try to oppose. No, you cannot
Yes,
come
sir.
with me. It will tell it, that's it. So the phase difference between these guys are phi. So you have to be very careful about this kind of circuit. Okay. Now we will see.
Yes, sir.
I hope it is clear. Okay. I am moving to the another circuit. Next is 3 series RLC circuit. Okay. Series RLC circuit. We have a voltage V. Now we have a resistance R. We have a inductor, and this is the phasor V. Okay. Be careful. I am talking about the phasor. You will see this phasor in power system. In there you will be talking only about the phasor. Nobody will tell you clear phasor. That's a problem. So you see here VC, and this is VL. This we can mark like this, no problem. VC, VL, and R. Now we will see what will be the situation. What will be my VR? VR, there will be a current phasor which is I.
Current has
What
the
will
reference.
VR? VR is, yes, current should be the reference, and VR is I into R. And what is VL? I into j omega L. That means it will be 90 degree, right?
Yes,
Yes.
sir.
And what will be VC? What will
I
be
into
VC?
1 over j omega c.
Minus I.
Yes, 1 by j omega C. I can write like this. My j omega L is ZL, is nothing but j omega L. Or this is same as j into XL. XL means omega L, and ZC is 1 by j omega C, which is
Minus J
nothing
by
but
omega C.
1. Okay, that's also true. 1 by XC. Okay, that is also you can say. Okay, 1 by, okay, that's also you can say. Minus, okay, that's this notation C is 1 by j omega C. Okay. Now we am going to draw my current. This is my current. And what will be the direction of VR? VR will be in the same direction. And what will be my direction of L? VL will be leading or lagging? VL will be
It will be
going above,
leading.
right?
Will be leading.
This is, yes, VL. Yes. This VL I am talking this, the magnitude, okay? I am talking about the magnitude of this guy. That means magnitude of VL, okay? We have already shown the angle is 90 degree, no issue. Now we will see what will be here.
VC.
It is going
The
down,
VC.
it is VC. It's minus 90. So there are two vectors which are acting in the opposite direction. What will be the net result?
It's up to the which one is greater.
Yes, which one is greater? That is it. So we have two situation. If we have two situation, two, no, not only two, we have three situation. So we will see now case one. That means VL is greater than VC. So in that situation, we will see there is a current I, and you have one is acting like this, another is acting like this. This is your VC is small, VL is higher. So what will be the resultant? The resultant will be like this, VL minus VC. Am I correct?
Yes, sir.
Yes.
And the net resultant voltage V will be here, right? This will be my V. So you can easily find out what is V. Magnitude of V will be equal to VR square plus VL minus VC the whole square. That's it. And what is the power factor? Cosine of phi. Cosine of phi will be, this is VR. So VR V. That's
VR by
it.
V.
Now we will see, yes, it's very simple. Now we will see what is my case 2. Case 2, that means VC is greater than VL. Now what is the situation, voltage which is leading? My current I
No, the
is
voltage is
lagging,
leading the
right?
current, sir.
Voltage is leading the current, or we can say I is lagging the voltage. Am I correct? If
Yes,
I is
sir.
lagging the voltages, the circuit will show which nature? Inductive or capacitive?
Inductive, sir.
Inductive.
nature.
Yes, circuit show inductive. Even though capacitor is there, inductor is more powerful. That's why inductive. You understood? Even though in the circuit both are there,
Yes, sir.
inductor is more powerful. That's it. So the total behavior of the total character of the circuit will be inductive. That's it. Now we will see another thing. VC is greater than VL. So we have now the current as the reference like this. This is my current. The voltage of VR will be like this. VR. And inductor is having something like this. This is VL, but my capacitor is more strong. Capacitor reactance is more strong. So this is VC. Okay. So I have a resultant vector like this. You can say this is the angle phi. So not this one, sorry. You have to show the resultant first. What will be the net result? The net
VC
result
minus
here, it
VL.
will
It will
be
be
VC minus
VC minus
VL,
VL,
right?
sir.
So my
Capacitive
result
nature.
will be, yes, the result will be like this, and this is my V, and you can see my phi. So in this situation, my V will be equal to square root of VR square plus VC minus VL the square, okay? And cosine phi will be equal to VR by V. But you can see that the current is leading the voltage. You understood? Or we can say the
Yes,
voltage
sir.
is lagging. Voltage is lagging. So what is the nature of this? Is it capacitive or inductive?
Capacitive.
It is
It is,
capacitive nature, sir.
yes, capacitive, because it is more dominant. Okay, it is dominant. Now we will see another case. Case 3, VL equal to VC. Both are same. What will be the
It is
situation? That's
resistive
very
nature.
beautiful. We will see, yes, we have the same thing. Okay, I am not going to draw the circuit. So what will be the situation? This is I, and you can say your VR is like this. VL is like this. VC is having the same magnitude like this. So the net result will be 0. So the total voltage will be in this direction, and the phi will be equal to 0. So the cosine phi will be equal to what? It will be 1. Okay.
Yes, sir.
And V will be equal to VR. That's it. Because other things will cancel. V will be equal to VR. So V will be equal to VR. So cosine phi equal to 1 means what? Power factor is equal to maximum. Power factor is maximum. You understood?
Yes, sir. Yes. Doctor,
This is the
I have a
idea.
question, sir.
Yes. Yes.
If we said VL equal to VC, does that mean
Yes.
C equal to L? Another way we can say
No, no.
5
No,
farad
no, no,
equal
no,
to
no.
4 Henry.
No. I am saying magnitude of VL is equal to magnitude of VC. And what is my magnitude here? I into Z is equal to I into ZC. That means I you can cancel. That means ZL is equal to ZC. Understood? What is ZL? 1 by J omega, sorry, it's J omega L magnitude is equal to 1 by J omega C. If I'm taking the magnitude, I will remove the J. That means I can say that omega L will be equal to 1 by omega C. This is the condition actually.
Oh, yes, sir. I get you.
Doctor.
Yes. Yes.
So here we shouldn't draw the VL and VC in the diagram, right?
Yeah, VL and VC I have drawn it, but you see here one is opposite to other, right? This is
Yes.
90 and this is minus 90, so they will cancel. So the total result will be 0, which will be in the same direction of VR. You understood? The net
Okay.
result will
Yes,
be in the
yes.
same direction of VR. That's it.
Okay.
It's cancel each other. Okay, that's the idea. So the net result I can draw like this. This diagram I will draw like this. This is my I, and this is my VR, also my V. Both are in the same direction. You understood? Now
Yes.
the diagram will be reduced to this form. Okay, so this is how we will start from here. We start here, and this is the final form. Okay, final form.
Okay.
Omega here is
And we
same,
will
doctor.
call
Therefore, we can cancel.
omega. What you're saying?
L equal to 1 by C.
This is omega, which is equal to 1 by omega C. What we can do?
We can cancel omega also.
How?
No. Sorry.
If it one is the numerator and another is the denominator.
Yes,
Okay.
yes, sir.
So L is not. It doesn't mean that L equal to C. So omega L is equal to 1 by omega C means, suppose you have omega equal to 1 hertz. Then this is also 1 hertz. So L it should be equal to 1 over C. If L is equal to 1 Henry, then this guy will be, if L equal to 1 Henry, then both will be same. Otherwise, it is not equal. Okay.
Yes, sir. Yes.
Understood. So that's it. Now we will see something known as the parallel RLC circuit. RL circuit. It's very easy. In parallel case, this is the parallel RL circuit. If you have a very complex circuit, you can draw the complete phasor diagram. It will be like this. Lot of things will be there. You have to. You will see this kind of diagram only in machines. Lot of things. You will see lot of connecting parameters like this. Many phasors. You understood? I am drawing a very simple things. Parallel, series, everything. All very simple circuit. But if you are thorough with this circuit while studying the machines, it will be very easy to draw the phasor diagrams. You understood?
Yes, sir.
We took it like this in the bridge rectifier.
Bridge
It
rectifier.
has a very
What is a
complicated,
bridge?
yes. It has a difficult phasor diagram.
Bridge rectifier is not having any phasor diagram. Bridge rectifier is just a rectifier, right?
We took it in measurements, I think.
Oh, okay. Maybe it may be used the coils or something like that. Okay.
Yes,
Bridge rectifier with some. Okay. It is not so complex diagram anyway. But in machines, you know, in machines, generator, in dynamo or the DC power generation, or sorry, AC power generation and all, you can see the field winding, the armature winding, all these things, and you will be applying some sinusoidal voltage to this.
Yes.
So
And everyone has current, separated current.
all these are coil, and this coil will be having inductance. So to get maximum, to extract maximum power out of it, the power factor should be very close to 1, correct? To get maximum power out of it, we should
Yes,
have a
sir.
power factor which is very, so for that we have to add some more things in the circuit. So all this can be
Capacitors.
determined. Yes, all these things will be determined by using phasor diagram. How much to add, how much to, what to do with the circuit, what is the situation of the circuit can be completely analyzed by using phasor diagrams. Understood? That's why we are studying
sir.
this. It will be helpful for you, inshallah, in studying the machines. I think Ryan is very much interested in machines, so you should study this
Yes,
thoroughly.
sure, sir, of course.
Okay. So this is the current I, and this is the R, and you have an inductor L. Okay, now this is the current IR, and this is the current IL. Now what will be same here? Voltage will be same, right?
The voltage.
The voltage, sir.
Yes, voltage will be same. So what will be the reference? So the reference voltage, that's the main thing. So voltage will be my reference here. Okay, now I will talk about the current. Now what will be the current IR? IR is equal to, what will be the current IR?
V by R.
Yes, the voltage, suppose here it is V, then it will be V by R, because I will talk only with respect to our reference. That is the main thing. You see, this is the reference. This is guy is the reference. So this I will talk with respect to reference. So this is the idea in any engineering problems. We will be keeping some reference, and we will talk some other parameters in terms of the reference. This is an idea or a usual convention which is used or followed in electrical engineering and in many engineering branches. Okay, so we will talk about IL. IL is V by ZL. Am I correct? This is V over J omega L. You see, there is 1 by J. 1 by J means what will be the phase? You can see 1 over
Minus
J.
90.
Yes. So first of all, I will draw my VR. I will first show VR. It will be in the same phase because it doesn't contain any complex number. But the other one will be minus 90 degree. So this will be my IL. Okay, this is my IL, not VR actually, IR. Okay, this is IR. Sorry, IR. So what will be my net current? The resultant current will be in this direction. Am I correct? This will be my, yes, this is my I. So I can talk about now I here, and this is the phase difference. Okay, now this is my output, and this is my, sorry, no, this is my input. Input is my current, and this is my output. So I will talk
The output always refers to, Doctor. The output, we put the output always as reference.
No, it's not like that. Okay, you can avoid this convention. I think that's better. I can talk in different way also. I will talk about my current. You can say here current. What will happen to the current? Okay, what will be my I? I will be equal to square root of, yes,
IR square plus
you
IL
can
square.
talk about, okay. Whenever you are talking about the power factor, you will say my current is lagging the voltage. That is the good convention. Other thing, it may be confusing you, the input and output convention that I have explained. That's why I am removing this thing. Okay, this idea may be confusing you sometimes. We will always talk about the current is leading or lagging. What is the situation of the current? Okay.
And determine the input and output because of the source, Doctor, right?
Yeah, I will talk about just one thing. Okay, cosine phi. What is cosine phi? Cosine phi is I Am I correct? Now,
Yes, right.
I will talk like this. Please remember
by
this
I.
idea. Please remember.
IR
No,
by
doctor.
I,
No, doctor.
doctor.
I will talk
IR
about
by
current.
Over I.
Yes. Thank you. So talk about this idea. My current is dash voltage. This is the idea. Okay. I will use this idea. Is leading or lagging? I will talk about the current and voltage.
Lagging.
Current is dash volt. Yes, lagging. So I will say that my power factor is actually lagging power factor. Okay, lagging. You understood? Lagging. This is the idea. You just remember this. So I about the current, then I will talk about what is happening to the voltage. So current is lagging the voltage. Okay. When I talk about the power factor, I will be using this idea. You understood? Current.
Yes, sir.
Yes, doctor.
Yes. Okay. Okay. Now we will see. This is phi. Now we have a current source, parallel RC circuit. Okay. Parallel RC. So you have a R, you have C here, and you are giving a current phasor. Don't forget this is a phasor I am talking. Phasor. So what will be, this is IR and this is IC. So what will be my voltage V? What will be IR?
V by R.
V over R. V over R.
V over R. Okay. And what will be my IC? This is, so V over 1 by j omega C. Am I correct? So this become
Yes.
VJ
j
omega C.
omega C. Yes, this is my IC. So what is this angle? Is it 90 degree or minus 90 degree?
90.
90.
Yeah, 90. Okay. So you can see first, what will be my reference? My reference will be voltage or current. What will be my reference?
Voltage.
The
My
voltage,
reference
sir.
will be voltage. Now I will talk about my currents. What is the situation of IR? Is it in the same direction?
Yes.
And my IC is going up actually 90 degrees. So this is my IC. So my resultant will be like this. This will be my I. So what will be the common for I? I will be equal to square root of
Leading.
IR square plus IC square. Okay. And what will be my cosine phi? Cosine phi is
IC by I.
IR over I.
IR by I.
I. And you can see first current is dash the voltage. Okay. Is it leading or lagging?
Leading.
Leading, sir.
Leading. The current is leading. So this is a leading power factor. Okay. The power factor is a leading power factor, we will say. Yes.
Doctor, can you tell me please why
Yes.
it's leading?
You see here, this is V and this is the positive angle, anti-clockwise. Anti-clockwise means positive angle. You understood? So if you move like this, you are going to what? I. So the angle is positive. Positive means it's leading. So you can see here current is leading the voltage, or I can say voltage is lagging the current. So if both are walking, voltage will be here, this is I. So current is leading the voltage means current is in front of the voltage. You understood? The angle between
Yes,
these
doctor.
guys is phi. Okay, that's the idea. So basically we will not say the current is leading the voltage. Okay, we will not say the voltage is lagging the current. That is not a good convention. Internationally we will be using a standard. If everybody is talking in the same language, then it's very easy to understand. If you are assuming something and I am assuming a different way, opposite way, then it will make a confusion. You understood? That's why we are using this, following this convention. At first we will be talking about current, then voltage, then what happens to it? Current is leading the voltage. I hope it is clear, Abdulaziz, everybody, right? Majid.
Yes,
It's
sir.
okay.
Yes.
Okay, so don't forget this. Whenever somebody tell you about leading, lagging, don't confuse what is current, which is first. Don't confuse. First one is current. If somebody is saying you, I have a lagging power factor, the meaning is the current is lagging the voltage. You understood? If somebody is telling you, I have a leading power factor, that means that the current is leading the voltage. It is not voltage is leading the current. It is actually current is leading the voltage. That is the standard. Okay.
Yes, sir.
Maybe some guys may be using in the another way. If they are using in another way, they should specify it with a sentence. Otherwise, everybody will get confusion. You understood?
Yes, sir.
Okay.
Yes.
Now we will see one more circuit last. Okay. I think okay.
Doctor, what's the actual meaning of the power factor?
The power factor I told you just before. Now, power factor actually. You know what is the power in the circuit? Power. Okay, I will explain a little bit. Power factor. Suppose you have a voltage waveform like this. Is it clear? This is a voltage waveform. V of t is a voltage waveform. Suppose you have a current waveform, which is delayed version. Okay, the current is delaying the voltage. That means the current is lagging the voltage by some angle. Let's say angle is not 90 degree. That will create problem. Now you see here, this is my delay. So my current is starting from here. Sorry, both are having same frequency. So my drawing may not be correct. That's, please try to understand this. Okay. Now, so I can write like this. Okay. This is my current, I of t. Then what will be my power? Can you tell me what is the power? Instantaneous power, P of t, is nothing but V of t into I of t. Am I correct?
Yes, sir.
Yes, sir.
Okay. So what will happen if both are waiting at the same time? If voltage is like this and the current is at this same line, if both are having phi equal to 0, this is the angle phi actually here. If phi equal to 0, will I get maximum value or not?
It will. No,
Yes. So I will represent now here V of t as cosine of, just remember here, V of t as cosine of t, but my I of t is having a delay, cosine of omega t minus phi, let's say minus phi, something, whatever. Okay. It's cosine of omega t minus phi. It's okay. This is a delayed version. It's starting from here.
Yes, sir.
Okay. So I can extend like this also, no problem. So what will be my power? My power will be V of t into I of t. It's nothing but cosine of omega t into cosine of omega t minus phi. Am I correct?
Yes, sir.
This is my P of t. So what will be cosine of omega t into cosine of omega t minus phi? Cosine of a minus b. What is the formula for this? Cosine of a minus b. Yesterday we have checked, I think so.
I don't memorize it, sir.
Cosine of a minus b.
I will check it.
What will be the value?
It is cosine A, cosine B.
Yes.
Is it plus or
Yes.
minus? Oh, it's
Here it
minus.
is minus.
So it will be cosine A into cosine B
Yes.
plus
Yes.
sine A into sine B.
Sine b, right?
Yes.
That's it. Okay, so you can see here I have a cosine square. If I multiply cosine square omega t square into cosine phi, right? This is
Yes, sir.
1.13. Then plus cosine omega t into sine omega t into sine phi. So I have two terms here in the power. Okay, this will be my instantaneous power. Now you can see one term is cosine phi, another term is sine phi. You can classify these two terms into two things. One is known as the active power and another one is the reactive power. That means this power is actually coming by the power drop across the resistance, and the other thing is the reactive power. It is the power which is exchanged between, it is stored in the energy storing element. It is the power exchange between the source and the energy storing element. You cannot, in a DC circuit, actually you can always think like the power will, if you have a DC circuit like this with a resistance, you can see that always power is flowing from the source to the load, right? This is the load and DC
Yes,
source.
sir.
But in AC it is not always like that. The power will flow from source to the load and also from load to the source. Yes, there will be a reverse power flow also. The power stored in the inductor and the capacitor will be flowing back to the load. Sometimes not load, may be flowing back to the source also. You understood?
Yes, sir.
Because of this phenomenon, you are studying power system. Inshallah, you will study in detail. I am not going to explain that thing here. Okay. So
Yes,
you
sir.
can see there are two terms, but if phi equal to 0, what will be the situation? Please tell me what will happen to the second term if phi equal to 0.
Second term will be 0, sir.
Second term will be 0.
Will be
It
zero.
will be 0.
Yes,
And
phi
will
equal to
be 0.
phi equal to 0 means the network is purely resistive, right?
Yes, sir.
Yes.
Yes. So if the network is purely resistive, you will get only cosine square omega t. You will not see cosine phi. Cosine phi become 1 and sine phi become, second term becomes 0. So the inductor is not there, so no reactance is there. So you will get only the actual power absorbed by the resistor. But the other thing is it is having another
Very power
significance.
only.
It is, yes. So you have two power terms actually in a complex AC circuit. You have two components. One is the active power and one is the reactive power. Reactive power is something which is not useful. For example, if you are connecting a bulb is a coil. You know, bulb is a coil, right? It is having resistance and it is having inductance. You know,
Yes,
bulb
sir.
filament is a coil. So because of this coil, maybe some energy will flow back to the source, and this is not useful. You will not get light because of it. Am I correct? You will get light only because of active power.
Yes, sir.
So
Yes.
the amount of, so how you can determine whether active power or reactive power is there? If cosine phi equal to 1 means you have only active power, no reactive power. If cosine phi equal to 0 means you have only reactive power. If cosine phi equal to 0.5 means you have both. You understood?
Yes, yes.
Yes, sir.
So the cosine phi is having a good significance. Actually, it is having a very high significance in determining the characteristics or behavior of a RLC network. That is why we are using this power factor. That's why I am always calculating this power factor. I hope this is clear to you. More explanation, inshallah, you will see.
Clear.
The power system course will start with this. Actually, it has to be started with this. This is the basics. I don't know what will happen to you, but it has to be started with this convention. I hope it is clear. I think so, right?
Yes, sir. Clear.
So we will see
So
one more circuit. We will see one more circuit here.
Clear, Doctor.
Parallel, yes, parallel RLC circuits. This AC is very beautiful thing. You can see a lot of beautiful ideas in AC actually. This is R. Here also the analysis is same. I will leave to you actually this analysis. You will have three cases. You know what are the three cases? If the reactants become equal, what will be the situation? Everything
Yes,
you
yes.
know. So I am not going to solve this. I will leave to you. Okay, this you can solve it. Just
Yes,
so
sir.
try to solve it. I will, instead of that, I will do a problem. Just I will do a problem and I will wind up this part. Okay. I need one more lecture just for explaining the phenomenon which is known as the resonance. Okay,
No problem,
inshallah,
sir.
I will conclude with that. Okay.
okay.
You have a AC source.
Tomorrow, sir.
You have an
tomorrow?
ammeter. We will
12
see
o'clock
next week,
tomorrow?
inshallah. Okay.
Next week.
Not tomorrow. Okay. Tomorrow, this week ahead, actually I have some work. That's why.
Yes, sir. Yes.
So next maybe Tuesday, inshallah. Just Tuesday we will finish. Okay, inshallah.
Inshallah, sir.
One lecture. So you have an ammeter. It is showing that A1, this is an ammeter. Okay. A means ammeter. All are ammeters. All are ammeter. Okay. Ammeter, you know, it will measure current, right? So A1 is showing a reading. It is showing a reading which is 8 ampere, and A2 is an ammeter. This is R, this is L. It's an RL network, and A2 is showing an reading which is 6 ampere, I think. Okay, 6 ampere. Then what will be the reading in A? That is the question.
8 ampere or 5 ampere, sir?
It's 8 ampere, 8 ampere. 8. Okay, 8.
Yes, sir.
You have an AC source which is V, then or I, you can say any AC source, whatever. What will be the reading? The current is
It is
8 ampere.
addition of 2, A1 plus A2.
Are you sure?
According
This
to
is
the
AC.
KCL, sir.
KCL is true in AC circuit, but you have to write the KCL in terms of phasor. I told you.
But what's the phasor of the ammeter, Doctor?
The phasor, actually, we don't need the phasor, everything. I told you there is a resistor. The resistor current to the resistor is A1. Actually, that is ammeter is showing 8 ampere. And another one is an inductor. Okay. And inductor current, you know, this is a parallel circuit.
Yes.
So what will be the current through the inductor?
Oh, yes, sir. I understand you.
We just see now. You understood? You see
Yes,
this
sir,
problem.
yes. There will be angle.
There will be an angle.
Magnitude
See, this is
and
going
equal
down.
square root 2.
So this guy is going down. This guy is going down with 6 ampere. So I am asking, what will be A? What will be the current here?
Doctor,
The current
excuse
here
me.
will be, yes, the vector.
The
The square root of 8 square.
phasor,
Yes,
the
square
phasor
root of 8
diagram,
square.
the standard is the voltage, sir. You can.
Okay, this is not a problem actually. The voltage is same. This is the voltage, and this is 8 ampere. This is the voltage actually? You can say here. I will not represent here. This is the voltage. Okay, voltage, and this is my A1 is showing the reading like this, and this is the reading of A2. Now what will be A? This is the reading of A. It will be nothing but square root of, that is square root of 64 plus 36. That means square root of 100. That is nothing but 10. So it will be 10 ampere. So A will show 10 ampere. And what will be my, so this is 10 ampere. What will be my power factor? Cosine phi. Cosine phi is,
8
this
over
current is 8.
8 by 10,
8
sir.
over 10. That means 0.8. So 0.8,
0.8.
I will. And what is leading or lagging? It is lagging. I will talk
The
about the current actually.
the resistive are more.
Yes. Yes, it is a more inductance, the contribution of inductance is less in this. Okay, that's why you are getting 0.8. So don't simply apply KCL. You are everything, KCL is true here, but
Because
everything
this
is
is
in terms
AC,
of,
right?
yes, we are talking about everything in terms of phasors. That is the important of phasor. You understood? So if you are writing a KVL,
Yes, sir, I
you will get
understand.
the you will get the answer if you are writing a KCL or KVL or whatever. But you have to write a KCL or KVL in terms of phasors. You understood?
Yes, I understand you.
Yes, doctor.
Don't make that. So you can apply all the theories you have studied in DC, but you should be very careful. You should apply everything. You should convert everything into phasor. Don't just simply use. You can apply by using time domain equation, but time domain equation it will be very complex. You will be having a time domain equation in terms of cosine and sine. So if you write an equation with cosine or sine, you know how much difficult to solve by using that, right?
Yes, sir, yes.
So you will use the phasor. Whenever you are considering the phasor, you should consider the phase angle. So you have to be very careful about the angles. So the total current will be the vectorial sum. We will call this kind of sum, actually it is the vectorial sum by using vectors, vectorial sum. It is not simple sum. In DC, actually you can have a simple sum, but this is the vectorial sum. That is it. You understood? Yeah, the other one is scalar. This is a vector because it contains magnitude and phase. That's why it is a vector.
Yes, understood, sir.
So simple sum will not work. As you told 8 plus 6, it is 14. That will not work because it contains the magnitude and phase. Because of that phase, it will create problem. So you have to consider this 8 ampere as a vector and 6 ampere as a vector. Then you sum it, then you will get the result as 10 ampere. That is the answer. You understood? That's the idea in solving
Yes,
this
sir.
kind of problem. Shall I give one more problem and stop? That's a beautiful problem. That's why I.
No problem, sir. No problem.
Okay,
Okay.
last one. Okay,
No
I'm
problem.
concluding with this. Okay, I will give one homework for you. Okay, I am not going to solve this. After that, I will give. You have a meter A1. Sorry, this is inductor. This is A2 and A3 is capacitor. Okay, that's it. So you have to draw phasor diagram and find the A. That is the question. But A1 I will give you. A1 is 6 ampere, A2 is 12 ampere, and A3 is 20 ampere. Okay, I think you can do it. The answer you can check, it's 10 ampere. A is 10 ampere, and the power factor you will get 0.6. You check this. Okay, I am not going to do this. This is an homework actually. So last one, I will give you that problem. This next problem, determine the current I through the network. So you have a 20 ohm resistance and you have an inductor. This is like this, and you have, this is 100 angle 0 degrees, that is the phasor, and you have a voltage here drop across here, it's 200 volt, and this is 200 volt. Now you have to find the current. What will be the current? here you might have seen something very odd. I have written 200 volt across the inductor and 200 volt across the capacitor, and my power supply is only 100 volt. Do you get any point from that? Hello?
It means the voltage across the resistance will be minus
How?
300 volts.
Yes, yes.
قدرت أجيب 263.
If we solve it by drawing phasor,
Yes. we
Maybe
will
they
draw it
are
by
working
drawing.
as a source also.
Yes, these guys are working sometimes as a source, reactive elements. It is supplying power from them to the source,
Yes, yes.
actually. But in this case, you cannot see it is working as a source. You will see something very different. If you have a current, if you are drawing the current, the current will be the reference. The current will be same throughout all the circuit. This is I, and you can see the voltage across, this is the VR will be in this direction, and what will be the direction of VC? VC will be going down, right? VC, and
Yes.
what will be the direction
VC
of
going
Yes,
down
sir,
and
yes.
VL going up.
Both will cancel each other.
VL? So both will cancel each other. So the net voltage will be in the direction shown here. It will be in the direction V. So V will be equal to the square root of VR plus VL minus VC the square. But VL is equal to VC here. Both are same. So
Zero.
V will be equal to square root of VR square, which is VR.
VR.
Yeah, yes.
So you can see this guy angle is 0 degree. So your 100, you take the magnitude, 100 is equal to the current into 20 ohm. What is VR? VR is nothing but I into R. So what will be the current? Current will be equal to 100 by 20, which
5.
is 5 ampere.
5.
So 5 ampere. Okay. Now, so what will be I of t? I of t, well, what will be I of t? The time domain equation for this current.
Real
My
or
time,
5 ampere multiplied by E of j omega.
yes, it will be just like this.
J omega.
5, yes,
J omega t.
it is the, yes, sorry. It is I of t, I will write. I of t is equal to the real part of I into e power j omega t. And my I is, this is 100 angle 0, so 5 angle 0. So this is 5
Yes.
angle 0 e power j omega t, and I have to take the real part. Since there is no angle, I can directly write the real part will be 5 cosine omega t. Am I correct? That is the real part, I of t. This will be my current.
Yes, sir.
I hope that you understood this point, or do I need to elaborate it? I can write like this. This 5 angle 0
Clear,
means what?
sir.
E power j 0. This is the polar, this is the exponential form. Am I correct? So I of t will be equal to real part of
Yes, sir.
5 e power j 0 into e power j omega t. So this is nothing but real part of e power j 0 is 1. So 5 into cosine omega t plus j sine omega t. And if I take the real part, I will get my current I of t is equal to 5 cosine omega t. I think this is clear to you. This is the current.
Clear, sir.
So my I of t is nothing but 5 into cosine omega naught t. And I told you about the RMS value. What is the IRMS? If I know the maximum value, I just divide it by square root of 2.
Square root.
I will get my, yes, RMS value. So the average power, I can find it by using RMS. So IRMS square into R. So it is nothing but 5 square by square root of 2 the square, or this like this, 5 by square root of 2 the whole square into R is 20. So this much watts. That is the average power. Got it?
Okay.
Yes,
Now what
sir.
is happening here? What is happening here? The network is purely resistive. The network is purely resistive. Network is purely resistive, right? And the current, if the network is purely resistive, the current will be maximum. Am I correct? Maximum, because there is no other reactant.
All right, sir.
Nobody is opposed. Yes, current will be maximum. So what has happened to this inductor and capacitor? These guys are playing with the ball. You can say like this. This is your inductor and this is your capacitor. They have a ball. The ball means energy. This is the ball. They are throwing between them. You understood? Inductor will transfer energy to the capacitor and capacitor will take the energy back. They are playing with them. You understood?
Yes,
So
sir.
that their net reactance becomes 0 and they doesn't contribute anything here. You understood? So that is what happening here. Okay. So I hope this is clear to you. And this condition, this is a special condition. This condition is known as, that means your VL is equal to VC. This condition is known as, or I can say this, j omega L become 1 by j omega C. This condition is known as the resonance. There are a lot of beautiful things related to the resonance. Inshallah, that I will complete inshallah in the next class. Okay. I hope it is clear to you, right?
Yes, Doctor.
Okay, thank you. Inshallah, we will see just one more class
Yes,
to
sir.
explain what is resonance. Resonance we will see in little bit detail. I will take only series resonance. There is another thing which is known as parallel resonance also. I will talk only about series resonance because that itself needs a lot of time. Okay, inshallah we will see in the last lecture, inshallah. Okay. Assalamu alaikum.
وعليكم السلام ورحمة الله.
Yes.
Doctor, why we only
Yes.
take